In this video, we're going to do the exercises on particle model of matter. And these are most likely the questions that will be in your exam. So how it's going to work, I'm going to read out the question, give it a little bit of a pause while you answer, and then I will give the answer and you can see if you were right. Let's get right into it. Number 1. Complete the following table by marking the state in which the material is at room temperature. Cork. Is it a solid, a liquid, or a gas? It's a solid at room temperature. Oxygen. A solid, a liquid, or a gas at room temperature? A gas. 1.3. Hydrochloric acid solution. Is it a solid, a liquid, or a gas at room temperature? A liquid. 1.4. Mercury. Is it a solid, a liquid, or a gas at room temperature? A liquid. Plastic. Is it a solid, a liquid, or a gas at room temperature? A solid. Copper. Is it a solid, a liquid, or a gas at room temperature? A solid. Chlorine. Is it a solid, a liquid, or a gas at room temperature? It's a gas. 1.8. Oil. Is it a solid, a liquid, or a gas at room temperature? It's an oil. Wood. Is it a solid, a liquid, or a gas at room temperature? It's a solid. Honey. Is honey a solid, a liquid, or a gas at room temperature? It's a liquid. Oh, there's more. Carbon dioxide. Is it a solid, a liquid, or a gas at room temperature? It's a gas. And hydrogen. Is it a solid, a liquid, or a gas at room temperature? It's also a gas. Rubber. Is it a solid, liquid, or a gas? It's a solid. Paraffin. Is that a solid, a liquid, or a gas? It's a liquid at room temperature. And salt. Is it a solid, a liquid, or a gas? It's a solid at room temperature. Number 2. Name 5 properties of solids. So these you should learn off by heart. So let's go. Number 1. Number 2. Number 3. Number 4. Number 5. The answer is number 1. Particles vibrate in fixed positions and cannot change position. Number 2. Particles are arranged in a fixed pattern. Number 3. Particles are very close together with small spaces in between. Number 4. Forces between particles are very strong. And number 5, it is in a solid form and it cannot flow because it's a solid. Oh, there's more. It cannot be compressed and other solids cannot move through without breaking it. This is a very long question, so 6 marks or 12 if it's a long question. Number 3, name 5 properties of liquids. Oh, it can be any of those. Okay, so any 5. Name any 5. Pause the video here. And the answer is properties of liquids are particles have limited movement and can change position. They have no fixed pattern, but the particles are close together. They're not necessarily touching, but there's small spaces in between. And the forces between the particles are weaker than in solids, and they take a shape of the container so they can flow, and they cannot be compressed. Name 5 properties of gases, so any 5. Pause the video here. And the answer is particles can move freely and in a disorderly way, and particles are far from each other with large spaces in between, and they are very weak and they exert pressure because particles collide the whole time, and it fills the entire container in which it is, and it can flow, and it is compressible. Number 5. What does each of the following words mean? 5.1. Condensation. Condensation is the change of a gas into a liquid. 5.2. Evaporation. Evaporation is the change of a liquid into a gas. Sublimation. Sublimation is the direct change of a solid to a gas. So it jumps one. It jumps the liquid stage. Boiling point. Boiling point is the temperature at which a liquid quickly becomes a gas. 5.5. Melting point. The temperature at which a solid becomes liquid. 5.6. Freezing point. The temperature at which a liquid becomes a solid. Number 6. Summarize the 3 states of matter by comparing the forces, spaces, and movement of the particles. So the teacher will give you solids, liquids, spaces between particles, and the forces. That's what you will get. All that, and then you must say solid, liquid, and gas. And you will probably get movement as well. So here we go. Solids. The spaces between the particles are very small. The forces between the particles are very strong. The movement in the particles in a solid vibrates in fixed position, and this is what the picture looks like of a solid. Liquids. The spaces between the particles are very small. The forces between the particles are weaker than in solids. The movement of the particles are limited, but it can change position. And this is what a diagram looks of a liquid. Gases. The spaces between the particles are very big. The forces between the particles are very weak. The movement of the particles are free and disorderly. They can just go anywhere. And this is a diagrammatic representation of a gas. Number 7. Complete the following diagram by writing the correct change of state on the arrows. So these will not be in here. These will not be here, and you will only get gas, solid, and liquid from the teacher. So you must write in all of these. So first of all, we have a solid, which is ice. Let's think about ice. It melts, it becomes a liquid. You heat it up, it becomes a liquid. And then you heat it up again, and it becomes a gas, which is steam. Then it condensates against the glass, and it becomes... if a gas condensates, it becomes a liquid. And if the liquid freezes, it becomes a solid. And sublimate when it skips from gas to solid. And deposit when it goes from a gas to a solid. Number 8. If the boiling point of nitrogen gas is minus 196 degrees, what can be deducted about 8.1. The amount of energy required to change the state from liquid to gas. So very little energy is required to change the state because it's already on a minus. So it will only have to get it 1 degree higher, and then it will boil. 8.2. The forces between the particles of this nitrogen. The forces between the particles will be weak. Number 9. Name a well-known material that sublimates. So we have dry ice, frozen carbon dioxide, or iodine. Number 10. Explain in terms of energy and particle model what happens when a gas is cooled. So what happens when steam is cooled down? The particles lose energy until the condensation point is reached. If it has less energy, it moves slower and closer to each other. The attractive forces become larger if the particles are closer together, and the state will change and the gas becomes a liquid, while the energy becomes even less. Number 11. Study the following table with melting points and boiling points, and then answer the questions that follow. Take room temperature as 25 degrees. Materials. P. The melting point. The melting point of phosphorus is -117, and then it's in liquid form. And the boiling point in degrees is 78. So, 11.1. Which materials are a solid at room temperature? Q or T? Solids. 11.2. Which materials is a liquid at room temperature? P and R, because the the melting point is less than the room temperature. 11.3. Which materials are a gas at room temperature? That would be S. Because it's already a gas at -164, so it will stay a gas then. Number 12. Study the following graph in the temperature versus time of a material that starts as a solid and answer the questions that follow. What are the changes indicated as A to D called? A to D. Is it condensation? B. Boil. C. Freeze. D. Melt. Oh, yes, it is. So A is the boiling, the condensation. B is the boiling. C is the freezing. And D is the melting. I would advise that you just read through the practical investigations on pages 162, just to get a good, the teacher might ask something, a random question. So just go through all these investigations. It might help you in the exam.